This is a video for AQA Further Pure Mathematics, Calculus Section 3.4, Integrating Using Arctan X. You should already know the results for the derivative of arctan x, so that arctan x differentiates to 1 over 1 plus x squared, and that the derivative of arctan x over a becomes a over a squared plus x squared. So looking at those, then we can look at the integral of the right hand side and say that the integral of 1 over 1 plus x squared dx must therefore be equal to arctan x plus, of course, a constant, or the more general result, which says that the integral of 1 over a squared plus x squared dx must be equal to 1 over a arctan of x over a plus a constant. So we can use these results to find integrals of functions which are in that sort of form. So an example of that, let's look at this one, which is the integral of 1 over 16 plus x squared. We can see, of course, here that we've got an integral which is in the form 1 over a squared plus x squared, where a is equal to 4. And so we can simply quote the result that this must be equal to 1 over 4 arctan of x over 4 plus c. So that was simply using this result, which says that this is equal to 1 over a arctan x over a plus c, where we could recognize that a was equal to 4. In general, however, we might need to do a little work to get the denominator into the correct form. So here we can see that we've got 3x squared rather than x squared. So the first thing we need to do is to factor out that value of 3, to say that this integral is the same as 1 over 3 multiplied by the integral of 1 over 16 divided by 3 plus x squared dx. Now we can see that we've got it in the correct form, a squared plus x squared on the bottom line, where a is equal to 4 over root 3. So if a is equal to 4 over root 3, then 1 over a must be equal to root 3 over 4, so that we've got 1/3 from outside the integral, root 3 over 4 arctan of x over a, so that will be root 3 x over 4, and then plus c. We can simplify that a little bit by dividing by root 3, top and bottom of this factor here, so that we get root 1 over 4 root 3 multiplied by arctan root 3 over 4 x plus c. So just looking through this again, then, we needed to factor out the 3 to give us 1/3 outside the integral. But once we've done that, then the value here is equal to a squared, so therefore a is 4 over root 3. The formula that we were using was that we wanted arctan x over a and 1 over a of that, where a was equal to 4 over root 3, 1 over a is root 3 over 4. In summary then, we can quote this standard result that the integral of 1 over a squared plus x squared dx is 1 over a arctan x over a. And there may be a little bit of work if the coefficient of x squared is not equal to 1, we take that value outside the integral by factoring it out. But once we've done that, then that standard integral can be quoted. Well, that's the end of this particular video, and indeed the end of the series of Calculus 3 videos looking at inverse trigonometric functions.